These will be your notes for Unit 4, Day 4 of Pre-Calc. If you would like to see the warm-up, the review question, or any homework questions we went over in class today, just look at the finished notes. So today we're going to talk about polynomial inequalities and rational inequalities and how to solve them and how to view their solutions algebraically and on their graphs. So solving a polynomial inequality by graphing. So if we want to solve this polynomial, x plus 3 times x minus 1 squared is greater than 0 by graphing, well, our first step is we want to sketch a graph of this guy. So we know that this would have zeros when x is equal to -3, x is equal to 1, and x is equal to 1. So this x equals 1 happens twice. So on that x-intercept, it should bounce off the graph. So at +1, and then 1, 2, 3, -3, those are going to be my x-intercepts. And if I multiply this out, x plus 3 times x minus 1 times x minus 1, my biggest x term, or my degree, would be x to the third. So my end behavior should be down and then up, or it falls and then rises. So it's going to bounce off of 1. It's going to go through at -3. So it's going to bounce off here and then continue up. So at 1, it bounced. And it cut through at -3. So now I'm going to look at what the problem was asking me to do. So it wanted me to figure out when that graph is greater than 0. So remember, that graph is like y. So basically it's asking, when are the y values greater than 0? So where are the y values greater than 0? Well, y values are greater than 0 as long as I'm above the x-axis. So it wants to know, where is the graph above the x-axis? And you're going to name these as intervals. Well, it's above the x-axis from here to here. It's 0 at both of those two places, so I'm not going to name -3 and 1. But my graph is above the x-axis between those 2 points. So this graph is going to be greater than 0 from -3 to 1. So -3 is less than x is less than 1. And then it's also above the x-axis after than 1. So notice all of those y values for that second piece of the graph are also above the x-axis. So that means y is greater than 0. So it's greater than 0 from 1 to infinity. So x is greater than 1. So my solutions in interval notation would be -3 to 1 union with 1 to infinity. So that would be how we could solve that polynomial equation by graphing. If we want to solve the next one by graphing, we want to know, where is it greater than or equal to 0? So when it's greater than or equal to 0, we want to know where it also equals 0 on the x-axis. So the zeros, or the intercepts, or the roots, are going to count this time. So we have x plus 4 times x plus 4 times 1 minus x. So my x-intercepts are going to be -4, -4, and +1. So at -4, it's going to bounce. So 1, 2, 3, 4. -4, it's going to bounce. And then x equals 1 is also a solution. If I multiplied all of the x's out, I have x times -x. So I'm going to have -x to the third. So the end behavior this time should be up and then down. So at -4, it's going to bounce. So it's going to start up. It's going to bounce off at -4. And then it's eventually going to have to go through 1. So my graph could look something like that. So this time around, once I have my graph, I want to know where it's greater than or equal to 0. So we want to know where the y values are greater than or equal to 0. Well, it's greater than or equal to 0. All of the places right here, all of those y values are greater than or equal to 0. And that's going to go from -infinity to 1. So all of the y values are greater than 0 as long as I'm smaller than 1. So x is less than or equal to 1, or on interval notations from -infinity to 1. So that's how we can solve them by graphing. Well, if we don't have their graph, or if we don't want to take the time to graph them, you can also solve these algebraically. So to solve them algebraically, you want to get one side to 0. So you want to get one side to 0. And then you're going to factor and solve. And then we're going to make something called a sign chart. So let's go through those first two steps. So we have 2x to the third. And I'm going to subtract the 8x over so that one side is 0. Then we factor. I can factor out a 2x from both of those, and I'm going to be left with x squared minus 4. And so then I have 2x times x, plus 2. and x minus 2 is greater than 0. So either x is 0, x is negative 2, or x is positive 2. So those are going to be my zeros. So those are going to be put into what we would call a sign chart, or it's kind of like a number line. So if I put these on the number line, I have 0, I have negative 2, and I have positive 2. I know that's where on my graph it would be 0. Basically what I want to know is what's happening in between those. So if on my graph, if you think of the x-axis as a number line, I have 0, negative 2, and positive 2. I want to know what's happening in between those zeros, right? Where is the graph going? Is it above or below those zeros? Well, we can just test numbers. So if this is negative 2, I could test to see what's happening at like negative 3. Or if this is negative 2 and 0, I could test what's happening at negative 1. I could test what's happening at positive 1, and I could test what's happening at 3. I could test any of those values to see where the graph is. Is it above the x-axis or below? So is it negative or positive at those points? So all I'm going to do is I'm going to plug in negative 3, negative 1, 1, and 3 into my factored equation. 2x times x plus 2 times x minus 2. So if I take negative 3 and plug it in, I would get a negative value, I would get a negative value, and I would get a negative value because 2 times negative 3 is negative 6, negative 3 plus 2 is negative 1, and negative 3 minus 2 is negative 5. So when I take negative 3 and plug it in, I get a negative times a negative times a negative. So all of those answers are going to be negative. Does that make sense? Well, 2x to the third minus 8x, the end behavior is going to be down and then up. So yes, this graph should start down. So all of those values should be negative. That makes sense. Let's test negative 1. So if I plug negative 1 in, I get a negative because 2 times negative 1 is negative. Negative 1 plus 2 is positive, and negative 1 minus 2 is negative. And a negative times a positive times a negative is a positive. And does that make sense? Well, none of those are double roots, so it's going to cross through, and it should come back down. So yeah, all of those values should be positive on the graph. And then if I plug in 1, if I plug in positive 1, I would get a positive because 2 times 1 is positive. 1 plus 2 is positive, and 1 minus 2 is negative. So again, when I plug into these three x's, I get a positive times a negative, so that's negative. So all of those values between negative 2, 0 and positive 2 are going to be negative. And now let's plug in 3. So if I plug in 3 to all of those, I get a positive times a positive times a positive, because 2 times 3 is positive, 3 plus 2 is positive, and 3 minus 2 is positive. So when I plug into here, again, I get a positive times a positive times a positive, which is a positive. And all of that matches up with what should have happened on the graph. So instead of having to graph it, you can make a sign chart. And then you look at the original problem. I want to know when those values, so I want to know when the y is greater than 0 on the graph. So where is it greater than 0? It's greater than 0 when it's positive. So I'm positive here, and I'm positive here. So on the graph, I'm positive when I'm between negative 2 and 0, and I'm positive when I'm greater than 2. Oops. Greater than 2. Or an interval notation from negative 2 to 0 and from 2 to infinity. So again, you could do it on the graph or you could do a sign chart. So let's look at the next one. It says x to the third minus 2x squared minus 9x minus 18, and I want it to be less than or equal to 0. So I want the y values to be less than or equal to 0, so I want to be below the x-axis this time. So if I want to solve this, I'm going to factor by grouping. So for the first two, I'm going to pull out an x squared, and I'm left with x minus 2. On the next two, I'm going to pull out a negative 9, and I'm left with x minus 2. Then less than or equal to 0. So I have x squared minus 9 times x minus 2 is less than or equal to 0. So x plus 3, x minus 3, x minus 2 is less than or equal to 0. So I have negative 3, positive 3, and 2. So those are going to be the zeros, or my x-intercepts. So on the graph, I know it's going to cross over at 2, at 3, and at negative 3. And if I look at my degree, that's the x to the third, I know that my graph should start down and end up. So if I were just to quickly sketch it, it wants to know where this graph is less than or equal to 0. Well, it's less than or equal to 0 here and here. Those are the values where my graph is underneath the x-axis. Or if I tried it with the sign chart, I know that I need to test at negative 3, 3, go in order, just like you would on a number line, 2 and 3. I know at all of those places my graph is equal to 0. So I'm going to test, I could test like -10, I could test 0, I could test 2.5, and I could test 10. And if I plug them into x plus 3 times x minus 3 times x minus 2, if I plug in -10, I get a negative, 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 which is a negative, and that makes sense because that's what's happening on the graph right here. If I plug in 0, I get a positive, a negative, and that would be a positive. If I plug in 2.5, I get a positive, a negative, and a positive, so that's negative. And if I plug in 10, I get a positive, positive, and positive, so that's be positive. So notice that's what's happening on the graph. I have negative values, then positive values, then negative values, then positive values. And it wanted to know where the graph was negative or where it was below the x-axis. So this happens from -infinity to -3, and from 2 to 3. And notice it's or equal to, so instead of parentheses, I'm going to put brackets on those numbers, except for the -infinity. So those would be my solutions to that one. So again, you can do it with the graph by sketching the graph, or you can do it on a sign chart. Rational inequalities using a graph. So again, if it's rational, these are a little bit more annoying to graph. So the sign chart's probably going to be our better bet. But again, the first step, we want to make sure that one side's 0. And so if I graph this, x minus 1, x plus 2, x minus 2, we have vertical asymptotes at -2 and +2. So -2 and +2. I'm going to get vertical asymptotes. I have a 0 or an x-intercept when x minus 1 equals 0. So it's going to cross the x-axis at 1. And then the y-intercept, if I plug in zeros for each of my x's, I get 1/4 as my y-intercept. And then I kind of want to know what's happening on this graph. So I'm going to just, well, the denominator wins, so I have a horizontal asymptote at y equals 0. And that's just end behavior, so that's telling me what the ends of my graph are doing. So I'm just going to go on Desmos and get the rest of this guy. Because normally what we're going to do on these is we're going to use the number line method, the sign chart method instead. So numerator in parentheses, x minus 1, and then divided by x squared minus 4. And so there's this guy. So it looks like a cubic graph in the middle and then 2 normal rational guys. So let's sketch that guy in. So he looks like this, and then a cubic that looks like this. So there's that guy's graph. So on this problem, it wants to know where it's greater than or equal to 0. So that's where it's above the x-axis. So we want to know, where is the graph above the x-axis? Well, it's above the x-axis here, and then everywhere here. So where does that happen on the graph? Well, that happens from the first vertical asymptote, so -2 to the 0, and the 0 happened at 1, so from -2 to 1. And then it happens from the second vertical asymptote was 2 to infinity. So those are the places on this graph where the graph is above the x-axis, where the y values are greater than or equal to 0. All right, so now on the next one, we want to solve where the graph is less than 0. So I want to know where this graph is below, not the y-axis, the x-axis. So go ahead and pause the video, graph that on Desmos, and see where its graph would be below the x-axis. All right, well, I know that this is going to have vertical asymptotes at 1 and -2, because that's what makes the denominator 0, and they're not wholes. So 1 and -2. I know that x equals 0, so it's going to have an x-intercept or a 0 at x equals 0, because that's what makes the numerator 0. And then if I multiplied it out, I'd get an x over an x squared, so the denominator wins. So I'm going to have a horizontal asymptote at y equals 0. And then from there, we're just going to use Desmos to graph this. So we have x divided by x minus 1, oops, I need parentheses, x minus 1 times x plus 2. And so it looks very similar to our last graph. So we've got these two pieces, and then it looks like a backwards cubic in here. And it wants to know where is that graph less than or equal to 0. Well, it's less than 0 here, and it's less than 0 here. So it's less than 0 as long as I am in that first piece, which was from negative infinity to negative 2. And then it's also less than 0 from 0 to the next vertical asymptote, which was 1. So from negative infinity to negative 2, the graph is below the x-axis, and from 0 to 1, it's below the x-axis. So that's how you can solve them with the graph. You can do it on Desmos. If you want to do it algebraically, these are a little bit more annoying, but it's the same idea. So step 1 is we need one side to equal 0, because I want to know when it's above or below the x-axis, and in order to do that, I need to have one side equal to 0. So we have 3x squared plus 13x plus 9, and then x plus 2 squared, and then I'm going to subtract that 3 over. And now I have is less than or equal to 0. Well, unfortunately, now I need a common denominator, so I'm going to put that over 1. And then I'm going to multiply both of these pieces by x plus 2 squared. So now I have 3x squared plus 13x plus 9 minus 3 times x plus 2 squared all over x plus 2 squared. Now I have to FOIL out that piece. So this is going to be negative 3 times x plus 2 times x plus 2, which is negative 3 times x squared plus 4x plus 4. So that's going to become 3x squared plus 13x plus 9 minus 3x squared minus 12x minus 12, and then all over x plus 2 squared. And so some things are going to cancel. The 3x squareds cancel. And then we are left with 13x minus 12x is just 1x. So I'm left with 1x. And then 9 minus 12 is negative 3. So I have x minus 3 over x plus 2 squared. So once you have one side equal to 0, and we do now, is less than or equal to 0. So since I want it to be less than or equal to 0, I want it to be below the x-axis because I want them to be negative values. So once I have one side equal to 0, you set the numerator equal to 0 and solve. And you set the denominator equal to 0 and solve. And now you're going to make a sign chart. So numerator equal to 0 and solve, denominator equal to 0 and solve, and then you're going to make a sign chart. So numerator is x minus 3 equal to 0. I get x equals 3. Denominator equal to 0, so x plus 2 squared equals 0. This would happen when x is negative 2. And so now I'm going to make a sign chart with negative 2 and positive 3. So negative 2, positive 3. At negative 2, my graph is undefined because that makes my denominator 0. At 3, my graph is at 0 because that's what makes the numerator 0. So I'm going to test negative 10, I'm going to test 0, and I'm going to test positive 10 because I want to know what's happening on each side of those. So if I test those, I'm going to plug them into x minus 3 over x plus 2 squared. If I test at negative 10, if I plug negative 10 into the numerator, I get a negative. If I plug negative 10 into the denominator, well, since it's squared, it's going to be positive. So that little piece of the graph is going to be below the x-axis because all of those values are going to be negative. If I plug in 0, I get a negative over a positive, so those are also going to be negative. If I plug in 10, I get a positive over a positive, which is positive. So where is this graph below the x-axis, or where are the y values negative? Well, the y values are negative here. So they're going to be, and they don't exist at negative 2, so I can't include negative 2. So they're going to be negative from negative infinity to negative 2, and then in between negative 2 and positive 3. And I want it to be less than or equal to 0. It's equal to 0 at 3, so this is going to get the hard bracket. And that's how we can solve them algebraically. So make sure that one side's equal to 0. Then for rationals, you set the numerator equal to 0 and the denominator equal to 0, and then you make a sign chart. So let's go ahead and try another set. So it's already equal to 0, so we're good. And since it's less than or equal to 0, I want to be below the x-axis, or I want where my y values are negative. So numerator equal to 0, so either x minus 3 equals 0, x plus 2 equals 0, or denominator equals 0, so x minus 1 equals 0. So either x is 3, x is negative 2, or x is equal to 1. And remember, this is going to be an undefined because that's what makes the denominator 0. So let's make a sign chart. So negative 2, 1, and 3. So at negative 2 it's 0, at 1 it's undefined, and at 3 it's 0. And now we're going to test. So I could test -10, I could test 0, I could test 2, and I could test 15. You can pick any numbers that fall on the left side of -2, in between -2 and 1, in between 1 and 3, and on the right side of 3. And I'm going to plug into the original function x minus 3, x plus 2 over x minus 1. If I plug in -10, I get a negative, negative, negative. So a negative times a negative is a positive divided by a negative. So those would be negative. If I plug in 0, I get a negative, a positive, and a negative. And that would end up being positive. If I plug in 2, I get a negative, a positive, and a positive. So those would be negative. And if I plug in 15, positive, positive, and positive. So those would be positive. I want to know where it's negative. So it's negative here. And it's negative here. So the solutions would be, as long as x is less than -2, so from negative infinity to -2, and it can equal -2 because that makes a 0. And I want less than or equal to 0. And then between 1 and 3. So from 1 to 3, it can equal 3, but it can't equal 1 because 1 makes the denominator 0. All right, one more. So same thing, but we need one side equal 0, so I'm going to subtract the 7 over first. So I get x over 1 plus 12 over x minus 7 over 1 is less than 0. I need a common denominator, which is going to be x, so I'm going to multiply all of these guys by x, except for the middle one, because it already has an x. And so I get x squared minus 7x plus 12 over x is less than 0. That would factor into x minus 3, x minus 4 over x is less than 0. Again, I want it to be less than 0. So I want it to be below the x-axis, or I want my y values to be negative. So I want to know where the sign chart is negative. So my sign chart is going to have x equals 3, x equals 4, and x equals 0, and that one's undefined. So in my sign chart, I have 0, I have 3, and I have 4. 0 is undefined, 0 or 3 and 4 make zeros. So I'm going to test -10, I'm going to test 1, I'm going to test 3.5, and I'm going to test 10. So if I plug -10 into x minus 3, x minus 4 over x, I get a negative, negative, and a negative. So those would be negative values. If I plug in 1, I get a negative, negative, and positive. So those would be positive. If I plug in 3.5, I get a positive, negative, and a positive. So those would be negative. And if I plug in 10, I get a positive, positive, and positive. So those would be positive. Again, I want it to be less than 0. It's less than 0 here and here. So it's less than 0 if I am smaller than 0. So from negative infinity to 0. And I can't equal 0, so that gets a parentheses. And then in between 3 and 4. So, oops, but I just want it to be less than 0, not equal, so we're good. So these are going to be parentheses too. And then in between 3 and 4. And those would be my answers. And again, you can always check these by graphing them on Desmos and making sure those are where on the graph the graph is below the x-axis, because that's where it's negative. All right, your homework is 4.5. If you have any questions, let me know.